Alright, so in this lesson we will determine if two shapes, are similar using a variety of methods. So, first thing we got to figure out is what similar is. If we want to determine if two shapes are similar, then we got to know what similar is, right? Similar is another word for or geometrically, well, you can think about it as proportional. How about that? Proportional in geometry, we'll say. So, this is our original person. If you can tell in this new version, they're blown up, but they're kind of look a little weird. Like their head looks smashed, like too wide and not narrow. No, it's just weird, right? This one, this person grew, but something still looks weird. This one looks good. This one is similar. This one is proportional. So I'll put similar because that's the same thing in geometry. This one's similar. If you look at these right here, so Ninja Turtle. This is our original Ninja Turtle. It looks a little weird. Number 3 looks a little weird, but this one is just a smaller version. This one is similar. This one's not. Right, I guess I should go back up here. Not. And we got this Mario, right? So if you can see, let me go up a little bit. Looks a little weird. This one's good. This one's proportional. So this one is similar. I guess I could write that a little better. Similar, not. All right, Thomas the Train. This one's the similar one, right? Similar, not. And the White Power Ranger. Oh, cool. Smaller version is similar, or appears to be similar, right? We haven't measured anything. All right, next page. So I'm going to show you 3 different ways of testing for similarity. I'm going to have to scoot this a tiny bit. Okay, so prove triangle ABC is similar to triangle DEF. ABC, DEF, AC is 20 units. I'll just put 20. CB is 24. I'll make that a little better. 20 units. CB is 24 units. AB is 28 units. It says DF equals over here 10 units, so DF is 10 units. FE is 12 units. And DE is 14 units. That 10 looks a little weird, so I'll fix that. 10 units, 12 units, 14 units. Like I said, I'm going to show you 3 different ways. I don't know why this looks so weird, right? I'm going to show you 3 different ways of showing whether, or determining whether 2 shapes are similar or not. So, first of all, we know they're the same shape, so they're good. I mean, they're both triangles, right? If they were if one was a square, it wouldn't be similar at all, right? So, but we need to check these lengths. So if you do something like this, we can create a table. This will bring back some memories of what we did with proportionality. So we have, let's do ABC right here and DEF right here. You know what I'm going to do? I'm going to use a different color. 10, 12, 14. 10, 12, 14, and then maybe I'll just use red or something. So this is ABC, and this is DEF. ABC, so I'm going to put 20, 24, 28. And with DEF, we put 10, 12, 14. Be careful because the 10 and the 10 have to go across from each other. I'll show you. Like the 20 and the 10 go with each other. They're corresponding. 24 and 12 are the corresponding measurements. And 28, 28. This corresponds to 14. Now I just need to figure out what I'm multiplying by. You can see that it's just divide by 2, divide by 2, divide by 2. But remember, if we don't know what we're multiplying by, we have to divide. So 10 divided by 20 is 0.5. 12 divided by 24 is 0.5 when you're doing a calculator. And 14 divided by 28 is 0.5. Remember, we're trying to figure out what we're multiplying by here. And in order to do that, we divide going backwards. So that's times 0.5 times 0.5 times 0.5. So since they're all times 0.5, since they're all multiplied by the same thing, they are similar. So I can represent this relationship, it should say relationship, by using the notation ABC is similar to DEF. Normally we put the little triangle, like triangle ABC is similar to triangle DEF, but you're fine. We'll just do it like this today. Let's do it again. Oh, before I move on, I don't have to put ABC first like I did here. I could have put DEF right here and then ABC right here. And it would have been times 2, times 2, times 2. But I want you to put whatever one on the left, whichever one on the right, and then just practice multiplying to the right, multiply to the right, multiply to the right. So you'll divide going backwards, divide going backwards, divide going backwards. All right, trapezoid ABCD. Actually, hold on one moment. All right, I think I fixed it. So prove trapezoid ABCD is similar to, so let's see, WXYZ. AB is 8 inches. And we'll use green again. Okay, so AB is 8 inches. I'll just put 8. BD is 4. CD is 6. AC is 4. WX is 10. XY is 5. ZY is 8. And WZ is 5. Okay, so let's go ahead and make this table. And let's do this one. So this is ABCD. So 8, 4, 6. I don't, well, let's see. 8, and then 4, 6. I'm just going to include all of them. 4, 8, 4, 6, 4. And then 10, 5, 8, 5. 10, 5, 8, 5. 10, 5, 8, 5. And this was WXYZ. So now we just need to figure out what we multiply by. We need to figure out what we're multiplying by. That way, that way, that way, and that way. So we do 10 divided by 8. And 5 divided by 4. 8 divided by 6. And 5 divided by 4. Oh, look. They're the same. So I only have to do really one of them, right, to figure out. So 10 divided by 8 is 1.25. So that's times 1.25. 5 divided by 4 is 1.25. So that's times 1.25. 8 divided by 6 is 1.25. 1.25. And then 5 divided by 4, that's the same thing, right? So we're good on that one. So these are all multiplied by 1.25. The scale factor is 1.25. So they are similar. So trapezoid, I can represent the relationship by using the notation ABCD is similar to WXYZ. All right, not too bad. I'm going to show you another method now, though. Okay. So I preferred this one when I was like a kid. So we're going to prove that ABCD is similar to WXYZ. MN is 4. NO is 3. OP is 2. MP is 6. And then TQ is 6 centimeters. QR is 4.5 centimeters. RS is 3 centimeters. And TS is 9 centimeters. Now I would do this. I would circle, and I'm going there, right? I would do the same with all these. Well, I'm going to do it one at a time. So we need to go from 4 to 6. I don't know what that is, like what multiplies, so I have to do 6 divided by 4. Oh. I would do 6 divided by 4. I'm going to write that, I guess, right here. 6 divided by 4 is 1.5. So this is really times 1.5. And I would do it right here. So I would do 4.5 divided by 3, which is 1.5. So this is times 1.5. I would do 2 to 3. That's 3 divided by 2, which is times 1.5. Oh, which is 1.5. So times 1.5. And lastly, I would do 6 to 9, which I have to do 9 divided by 6, which is 1.5. So it's times 1.5. They're all being multiplied by 1.5. Remember, you can do it the other way. You'll get a different number. Like 6 to 4 is 2/3. These will all be 0.66. If you go the other way, 0.66, 0.66, 0.6, repeating the other way. So they are similar. I can represent the relationship using the notation MNOP is similar to TQRS. Okay. Let's do it again. So this one gives us our number, so actually I could just do this. 12 corresponds to 6. Cool. And 6 divided by 12 is 0.5, so that's times 0.5. 16. Well, I'm going to write this in different color. It might be easier to see this time. Oops. Okay, 16 to 8 is 8 divided by 16, which is 0.5. I'll write that 6 a little better. Maybe I'll just have to write the whole 16. Okay. So that's times 0.5. And then we have this last one. So 18 goes to 9, which is 9 divided by 18 is 0.5. So times 0.5. And remember that these all have to say, if this one was 0.5, this one was 0.5, but this one was like 0.4, they would not be similar. But so far, we're good. They are similar. So triangle ABC is similar to triangle DEF. Okay, cool. One last page.